So this is the last part for the chapter 3.1. It's a Newton universal law. So they need to introduce another formula to calculate the mass of the sun and also the earth. Although we know there is a constant value, we know the sun was a mass, the earth was a mass, but some situation they want you to do the calculation. Okay, so we're going to see this one formula, what you need to know. Okay, let's see the first one. Okay, from here, they say mass of the earth. So we related three of the things lah. Earth, sun, later got moon also. So from here, the capital M normally stand for the bigger size of the object. So from here, if we compare the moon and the earth, so we're using the earth is a capital M lah, because the size is a bigger. So the small one should be the moon. So R stand for the radius. Radius between the center of the moon to the center of the earth. Okay, so this one we call radius of the moon orbits. Okay, after that we got period. Okay, now we add period already. Period means the time taken you want to round, one round. Okay, the moon want to round the earth for one complete rotation. So this one we call periods. Okay, after that we got V. V is a speed. Before that we learn for the centripetal force, because they want to move, is it? So this one we call linear speed of the moon. Okay, so this one is a physical quantity need to introduce first before we go through the formula. Okay, so we go through this one. Distance traveled by the moon when making one complete orbit around the earth. So the distance is 2 pi r. Okay, if the moon around the earth, that means this is just like the one orbit, there's a circle. Okay, circle the distance, normally we take it as a 2 pi r. Okay, the circle parameter. Okay, the circle parameter. So there should be the 2 pi r. Okay, after that, linear speed of the moon. Okay, linear speed of the moon, before that we know the V, what's the formula? Distance over the time. This one we call linear speed. Distance over the time. So the distance now is how many? The distance now is a one circle. So the one circle suppose is a 2 pi r for the circle. Okay, so from here we need to create the velocity related with the period. Okay, so we need to create the formula. So 2 pi r over the t, that one is a linear speed. Okay, from this formula. Okay, then we continue. Okay, before that, we learned two of the forces. One is the normal, the universal law. Okay, when starting, we learn already. Okay, the first one. Okay, second one, we're talking they want to move. They want to move, they got some of the force to pull it. So this one we call centripetal force, related with the velocity. So that means the formula got velocity. Okay, equation 1 equal equation 2, because both also pull to the center. So when I move together, so I find it, this one, these two become the same. So capital M is stand for the earth law. Small one is stand for the moon, is it? So actually, this one M and this one M, we can cancel each other. Okay, another thing you can cancel, there's a R square. This one R square, then this one R. Okay, when you just cross to multiply, this one R is at the top. Okay, when the R at the top, that means we can cancel upper and down. So later we see what formula you get it. Okay, this one I continue. This one M. This one M, that means I can cancel. This one R later go above. Okay, then after that, upper part and lower part also can cancel. So later you see what happened for V square. I just want the V square. So when I take the V square alone, so you find it as GM over R. So I now do the calculation I show here. Okay, this one cross to multiply. So R, capital G. Okay, wait, capital G. Okay, after that M. Okay, then equal V squared R squared. So the M no more already. So which one we can cut? The R. 1R. And this one cut become 1. Okay, finally I want V squared only. So you wait, the V squared is here. Okay, after that, your V squared this part. So the GM keep put here. Okay, then the R you move down. So they become R. Okay, so from here, this formula for the V square they get from the two centripetal force and also gravitational force. Okay, so from here, if the situation you want to find the mass of the Earth is okay, you straightforward, M equal V square R over G. Okay, you can find the mass of the Earth without using the time taken, also can by using this formula. Okay, if the question provide the periods, provide the time taken, then after that they never provide the radius, then you need to do the calculation. Or the question never provide the velocity, they just provide the radius, provide the time taken, so you need to find the mass. Okay, also can. So from here, if I take out the velocity, okay, no problem, I take out velocity. So the V square, just now we find already, V is what? 2 pi r over t. Just now you say the parameter of the circle is 2 pi r, then over the time there's a velocity, is it? So I bring this one up here. Okay, this one is a V square. V square means 2 pi r over t, then square. So this one is just now gm over the r. So finally, we cross over. You cross over, you want to find the m only. So if you want to find the m only, you make the m alone. So this one r must go up. Okay, then this one g must come down. So your left is a m. So finally, my formula, the square you just put in. Okay, must solve the square. So from here, 2 square become 4. Then the pi square. Okay, r suppose is a square. Multiply one more r, they become r cubed. Okay, then the g you bring down already. Then the g is no square because g is the other side to come down. But the t you got square because the t is original here. Okay, so finally you can find the mass of the Earth by using the formula got period and also radius. Okay, you also can find the mass of the Earth by using the velocity and also the radius. Okay, depend the situation, they give you what info. So this one formula they will provided in the formula list. Okay, so from here, this is one of the formula more a little bit complicated. Okay, either you find the mass sun and also Earth, or the mass Earth and with the mass moon. Both they pull each other. Normally the sun and the Earth, then you need to find what's the mass of the sun. Okay, if the Earth with other satellite, then you need to find what is the mass of the Earth. Okay, so now this is one of the formula. How to prove, you don't need to know. You don't need to prove, but you need to know how to get it. But the exam, they never ask you how to prove. You also need to know this one is what related. The capital M, the R, the T is what. This one you need to know. Okay, now we're going to see some example. Okay, this one question, they want to find the mass. Some situation, they want you to find periods. Okay, if they want to find the period, so you take out the T lah. T square equal 4 pi square r cubed over gm. Is it? If you want to find the T, so you need to square root. This one square root, then this whole thing square root. So you find the periods. Okay, depend the situation. So we need to know what is the R, radius. Okay, orbit of any planet or satellite. Then the T is the period of the revolution. Revolution means one circle they finish. So the formula you want to use to determine the mass of the Earth. Okay, normally they want to find the mass of the Earth or the mass of the sun. So we're using this formula. Okay, then the data you need to do for calculation for the mass of the Earth. So mass of the Earth means you want to count ME. So what you need to know the radius law. The radius of the orbit, any satellite or the moon. Okay, because the Earth is surrounded by the moon. Okay, Earth surrounded by the moon or other satellite. Okay, so you need to find either the mass of the Earth, the radius from the satellite to Earth, or the Earth to the other planet, okay, or moon. So that means normally the Earth is to the satellite and also the moon. So period revolution means one complete oscillation. If for the sun, normally sun and Earth, okay, or sun with other planet. So from here, the radius orbits by any planets. Okay, maybe they're talking about moon, maybe they're talking about Saturn, Jupiter also can. So that means other planet lah. So the sun and other planet. So also same period of the revolution of the planet to circle. Okay, to concern the sun. So this two is a factor how to do the calculation for the mass of the sun and mass of the Earth. Okay, normally they would just want to find these two mass only. So when they're talking about Earth, so the sure is surrounded by the moon or satellite. If they want you to find the mass of the sun, sure if the other planets lah. Example is the Earth law. One is the Earth is always surrounded the sun. So we need to count what's the mass of the sun. Okay, suppose this one mass of the sun of the Earth, we also know the answer. Okay, we know the answer every time we do, they go provided, is it? So when you do the calculation after you check, so normally the answer is there. Okay, you count an example, you count for the sun. Sun is 2 times 10 power of 30. So when you do the calculation after you show the mass, you get the answer almost near the actual answer, means you are correct already. Okay, although the question they got provided in a formula, but you still need to do the calculation to show what is the mass of the sun and also the Earth. Okay, so this one is the last part for the chapter 3.1. Okay, now we're going to see example 1. Okay, this one, example 1, you can refer the paper I sent to you. I label there is a tutorial 3.1. After that, I got part 3. Okay, you help me to add G. I think I forget to write the G. Okay, important formula. The first question, they start with the period of revolution. Okay, remember if they provide the G is how many? 6.67. Better we don't press the constant 39. Remember, I remind you to press the simple one, is it? Okay, constant 39, they're equal to the G. After that, they provide the answer, is it? The answer is quite long. So if the question could provide 6.67 times 10 power negative 11, so better using this one. Because I find it behind the decimal point that will affect the in front number. Okay, so better we using what they provide lah. If the question never provide, okay, you can using the short form. Okay, so from here we go through the first question. So you can see the first one. Okay, period of the revolution of the moon around the Earth. So moon around Earth. So that means normally they want to find is the mass of the Earth lah. Okay, they provide the period. Period is 2.36 times 10 power of 6 seconds. Okay, and the radius, moon orbit. Okay, moon orbit the Earth. The radius is this one. Okay, they want to calculate the mass of the Earth. So the info. Okay, info. So the G, we follow the question. This one is the G provided. So we got T, then we got R, then we do know what's the mass. So we're using this formula. Okay, when they're just asking about mass of the Earth, mass of the sun, sure, we're using this formula. Okay, apply all the things. Okay, just write 4 pi squared. Okay, later you press your calculator. Okay, then this one, remember, this one is a radius, the radius of the moon and also the Earth cube. Must put cube. Okay, then the bottom is a G. Then multiply the period. Period is this one, 2.36 times 10 power of 6. Remember, square. Only the T square. The G is never square. Okay? So from here, you can try to press your calculator. See what the answer you can get it. Okay, second question from your paper. Okay, the Earth revolves the sun. Okay, Earth and sun already now in a period of 1 year. Okay, now the question never exactly to tell you the time is how long. They say 1 year. So that means you need to convert, become SI unit later. Okay, and the radius also provided. Sun and Earth, the radius provided. Calculate the mass of the Sun. Okay, so from here, I need to find out 1 year first. So 1 year, 1 year, okay, we got 365 days. Okay, 365 days. And after that, 1 day is 24 hours. Okay, then after that, 1 hours is 3,600 seconds. These all things, finally, I want you to convert become second. So from here, we're going to show the info first. Okay, so 365 multiply 24 hours, multiply the second. Okay, so this one is the overall, you multiply, there's a period. Okay, period of the revolution, complete 1 cycle. This one is a radius, then this one is a G, then they want to find the mass of the Sun. Okay, we're still using the same formula, just put in all the info. Okay, 4 pi square. Okay, the R, 1.5 times 10 power 11, you need to Q. Okay, the next one is just a G. This one is the period. So that means just now I do the calculation. I get this one. Quite big at the number. Okay, after that, remember square. Okay, you go to check, is it the time correct or not? Okay, example 3. Why do all the formula come out already? Okay, we're going to see this one. A satellite of the mass 2,460. Okay, satellite, after that orbits a planet of the distance. Okay, or distance. Okay, distance 2.74 times 10 power 7 from the center of the Earth. When they say from the center of the Earth, then you save. That means you no need go to plus the H. Okay, they already told you that exactly the radius is how many already. Okay, after that, the uniform linear speed. They tell you the speed some more. Okay, so they mean this one formula must related with the speed one. Okay, calculate the centripetal acceleration. So centripetal acceleration, the formula is this one. Okay, A equal V squared over the R. So we show all the info first. Mass of the satellite, 2,460. Radius, this one is a distance between the both center, 2.74. Then they provided the linear speed. So what is the acceleration? So I just put in all the linear speed, 7,800 square. Still the same thing. Okay, you can using this one, F equal MA. Okay, if not, you can using just now I show you the formula. Okay, because you count the A already. So A, F equal MA, then you straightforward do the calculation, you get the answer. Okay, if not, you can redo again. M after that V squared, then over the R. Okay, it's the same thing because V squared over R is A. So MA. So this one is a calculation for short form. If they ask you the A already, so you don't need to bring all the thing in the formula. You can straightforward. This whole thing actually is an A already. So F equal MA. Okay, you just multiply the mass of the satellite. Okay, number 4 got diagram. They show about the two bodies with the mass capital M and small m. Okay, both bodies are placed in a space. So from here you can see both pulling each other with the 720 Newton. Okay, the strength of the gravitational force, okay, between the two bodies. So based on the Newton universal law of gravitational, that means the first one we learn, complete the following sentence. The greater the mass of the both body, okay, I show the formula again. Okay, this one is the first one what we learn. Okay, so they say the greater the mass of the body. So that means when the mass either one of the body increase, okay, what happened for the force gravitational attraction? So the answer should be bigger because the mass and force directly proportional. So the greater, both also greater. Okay, how about the force gravitational attraction? As the distance between the two bodies increases, that means the R. If you put the two body far away, so you find the distance become increases. The gravitational force sure decreases. Okay, so actually the definition for the gravitational force, they already explained about the formula. Okay, so this one is an info. Then we go to B. B is a question for yours. Do the calculations. Okay, so now you can see this one. What is the force? Gravitational attraction. If one of the mass is double, so I don't care lah, either one of the m double, and the distance of them is unchanged. So that means the situation like this. F, G, double M. So that means times 2 lah. 2 capital M small m over r square. So when the situation like this, they tell you what is the force. The force sure increase, but I don't know increase how many lah. So they want you to know what is the ratio. Okay, when I just make the mass increase double. Okay, so from here we just show the info. Okay, I go to using the another color. Okay, you can see this one. This one is a F. Same like this equation. So I want to show you is, if I take out the 2 here, okay, G, capital M, small m, then r square. Actually, this one is a F. It's a F just now I show you. So this one is a F prime. So that means another situation for the gravitational F lah. So when I make the masses increase double, so I find it they become 2 gravitational force. 2 original gravitational force. Okay, so they ask you, they already bigger how many times? They bigger twice only. Okay, if I double the mass. So how to do show the calculation? So this time we put F prime. Okay, F prime means the new gravitational force when the masses is double. So times 2. So from here, this thing, this one is the original F. Okay, so I can show F prime actually is 2 gravitational force. Okay, there's a 2 gravitational force. So many questions they will show like this.